Hello everyone. Welcome to one of the important topics in DBMS, the keys in RDBMS. Before going into the topic of the day, the keys in RDBMS, let's first understand why do we need keys in RDBMS. Let's assume there is a relation or a table, and this is the employee table, and we have the attributes in the employee table, the employee ID, the employee name, the SSN, the social security number. We can also consider this as an Aadhaar number in India, the salary, the phone number and email. And we have 9 tuples here, and these 9 tuples are just for example purpose. Now why do we need keys in RDBMS? Let's assume I'm going to increment the salary of John by 10%. In that case, I am informing the database with a query that increase the salary of John by 10%. And obviously database will be incrementing the salary of John by 10%. But the problem is there are 3 Johns that are updated in the database. 101 John, 105 John and 108 John. Do I want all John's salary to be incremented? No, actually I wanted 105 John's salary to be incremented. But what did I tell the database to do? I instructed the database to increment the salary of John by 10%. But all 3 John's salary will be incremented by 10% if I provide a query by referring the name of the employee, which is John. Instead, if I give update the salary of John who is belonging to a specific department. And that may be okay to some extent. What if there are 2 Johns in the same department and we wanted to increment the salary of only 1 John? Again, that will bring some inconsistency to the database, right? So the real problem here is identifying the unique tuples. If I want to do some operation with the database, I want to uniquely identify the tuples. In this case, if this John that I am referring, it should be clear that this John's record only is updated and not any other John's data. And instead, think this way. We know John's salary is 62,000 and we want to update the salary of John by 10% for this John. And if I give a query like this, update the salary who is having the existing salary as 62,000. Obviously, many people may be having the same salary. So the real problem is identifying the unique tuples, and that is why we need keys. So here we confirmed that name cannot be a key because there can be multiple people with the same name. So if I use ID number, and if we are sure that this ID attribute is unique in the table, then definitely that particular tuple will be identified and that particular tuple only will be updated. Just think here, update the salary of the person. I need not even give the name of the person. Update the salary of the person who is having the ID number as 105. So obviously this particular salary only will be updated because I am very clear with my query that I want to update the salary of a person who is having the ID number 105, and it is obviously this John who is having the ID number 105 because there will not be another 105 ID in the same table. This is how we can uniquely identify the tuples. So I hope now you understood why do we need keys, because these keys are actually required to identify the tuples uniquely. Let's now step into the topic of the day, the keys in RDBMS. When we talk about keys, we clearly understood that we want to uniquely identify the tuple. So for that we need keys. When we discuss about the relational database management system, we might come across a lot of key terms. The key terms related to key are super key, candidate key, primary key, alternate key, unique key, composite key, and foreign key. In this presentation, we will see all the keys one by one. Let's first start with the first key, the super key. What is a super key? Actually, the super key is like the superset, and this super key is actually the all possible keys that can be formed from a relation or a table. So if we have an employee table, and we can create any number of key combinations from this table. Say this ID number alone can be a key, or we can combine ID number and name as a key. We can combine name and salary to work as a key. So this is a superset. So why we are creating a super key? Of course, this is a key basically, and we are going to uniquely identify the tuple. And that is the real need for having key. And super key is not an exception. It is going to uniquely identify the tuple in the relation. Then why do we need super keys? Why not primary key or candidate key or any other key? Because super key is the superset from which we can derive other keys. If you are not sure, anyway we will see that with an example shortly. And let's take this example ID, and if this ID is going to have a null value, I'll put a question to you. Can there be a null value in this ID? I mean to say, can there be an employee without an employee ID? No, any organization will not encourage that because we want to uniquely identify that particular employee. In that case, every employee will be associated with the employee ID. Will every employee have a name? Yes, every employee will have a name. So obviously ID will be unique and this will not be null. So I can say ID attribute is unique and not null. And coming to this name attribute, if I make this name attribute as a unique attribute, it won't work because in a table there may be multiple employees with the same name. So in this case, this will not be unique. At the same time, every employee will have a name. So obviously this attribute will also be not null. And coming to SSN, the social security number or the Aadhaar number, the reason why I am picking SSN is in certain countries, every citizen will be assigned a social security number. Like in India, we have Aadhaar number. With Aadhaar number, we can uniquely identify that particular person. So this will also be unique and this will also be not null to some extent. Why I am saying not null? If a person who has not applied for Aadhaar, so he will not be having an Aadhaar number. But we need to ensure that every person is having Aadhaar number. So anyway, let's not go deep into this. For now, let's consider this SSN is also unique and not null. And coming to salary, every employee will be having a salary. And coming to phone number, employee may have a phone number or may not have a phone number. At the same time, this can be unique, but null values are also should be accepted in this field. What if the employee claims that he or she does not have a phone number? Of course, we are in the contemporary world, every employee will have a phone number. But there are chances that employee may not have a phone number. So we can't enforce that every employee should have a phone number, isn't it? So in that case, this attribute should accept null value. And coming to email ID, every employee will be having a unique email ID. At the same time, if there is no email ID, this column should accept null value as well. Now, why I am saying all this is that the key attribute, whatever we are figuring out, it should accept null values also. When we talk about the super key, now this super key is going to contain either one attribute or set of attributes, and there can be null values in the attribute. Say for example, if I am saying name and phone number as the super key, so name will not have null values, whereas phone number may have null values. In that case, the attribute or attributes which we are considering as a super key attribute may contain null values. So in this, I can say ID is a super key because it is unique as well as there is no null values. Of course, we may have an attribute which may contain null values also. One example for super key here is ID. And why name is not a super key? I'm saying name is definitely not a super key because there may be multiple people with the same name. When there is no uniqueness in the attribute which is acting as a key, then definitely that attribute cannot be a key attribute. So name attribute cannot be a super key. Let's see some example. So from this we can confirm that a super key is a collection of attribute or a set of attributes so that we can uniquely identify the tuple. And one of the important points to note about super key is that it may contain extraneous attributes. Say for example, ID alone may work as a key, but I can combine ID plus name together in order to form a key. Or I can combine ID plus SSN. Or I can combine name and SSN, the social security number, to work as a key. So what I mean to say here is, super key may contain extraneous attributes, simply extra attributes. The example for super keys are, remember, it is actually a superset. So here ID alone is acting as a key. So ID alone is a key, or SSN number is also unique, right? So in this case, SSN also can be a key, or I can combine ID and name to work as a key, right? So ID and name put together is also a key. And coming to the next one, ID and SSN works as a key. So ID and SSN can also be a key. So what I mean, ID and SSN I am combining together. And ID and phone number can also be a key. So this ID and this phone number is joined together as a key. So we can have multiple keys in a relation. And that's why I told you this super key may contain extraneous attributes. In this case, ID alone is enough, or I can combine with other attributes. This is actually a superset. It may have n number of super keys. So anyway, why we want all these super keys? Just to uniquely identify the tuple. Let's take one example, name and email. If you see, name is definitely not a unique attribute because many people may have same name, but with email ID, it can uniquely identify a tuple, right? And this super key is actually a superset. I hope things are clear to you now. We are done with the super key. With this knowledge, let's step into the next key, the candidate key. So just now we had seen that super key is the superset which contains all possible keys, right? All possible combinations, whatever we create, everything is the superset. Now from this superset, we are going to derive the candidate key. And how we are going to derive it? The minimal super key is actually the candidate key. Remember, the minimal super keys are called as candidate keys. So let's see this example now. We have a lot of keys here, I mean super keys. From this we will derive the minimal super key. Let's take the first super key, the ID. It has only one attribute. Yes, of course we can choose this. So the candidate keys can be ID. Then I have one more attribute here, SSN. I can take this also as a candidate key. Remember, if I take this SSN, ensure that the previously taken key is not having this attribute. The previously chosen candidate key is ID, which is this. So this is not having SSN with it. So ID is a separate candidate key. Now we are taking SSN as a separate candidate key. Let's come to this key, ID and name put together working as a key. Now in this case, we can't take it as a candidate key because there is an attribute ID which is already a candidate key. So we cannot take this key as a candidate key. Of course, it is a super key, but this is not a candidate key. Let's come to this. ID and SSN. Already ID and SSN are chosen as the candidate key. So this super key cannot be a candidate key. ID and phone number? No, because ID is already chosen. Name and phone number? Yes, because the already chosen candidate keys are ID and SSN. So we can have this name and phone number can be a candidate key. And again, ID and email ID? No, ID is already chosen. Name, SSN and phone number? No, because name and SSN are already chosen. Name and email? No, name is already chosen. ID, SSN, phone? No, ID, SSN are already chosen. And phone is also already chosen. Simply email ID? Yes, with email ID also we can uniquely identify some tuples, right? So email ID alone can also be a super key. In that case, since all the candidate keys are not having email ID, I mean all the already chosen candidate keys are not having email ID attribute, this email ID alone can be a candidate key. So what do we mean by a candidate key? The minimal super key. Remember, the list of candidate keys that you are taking from the super key, there should be no repetitions of the attribute. So if ID is there and it is acting as a candidate key, no other candidate key should have this ID attribute. So we are done with the super key and the candidate key. Let's now move on to the next key, the primary key. Now we have seen the list of candidate key, and this primary key is used to denote a candidate key. What is a candidate key? Just now we have seen, right, the minimal super key. So we have already derived the list of candidate keys from the super key pertaining to this table employee. Now the candidate keys are ID, SSN, name and phone number and email. Now just pause this video for a while and think which can be a primary key. Remember, primary key should be unique and it should not contain null values. So ID, can we choose ID? Yes, ID will be unique and it will not have null values. Can we choose SSN? SSN, yes, it is unique, and this SSN is incorporated in a country where every person in the country is having an SSN number. And of course, in that case, this SSN will be 100% unique and not null. Coming to name and phone number, there is an attribute which contains null values. So this key, name and phone number, they may be unique, but they are having null values in it because there is an attribute which may take null values. And coming to email, of course, with email we can uniquely identify the tuple, but unfortunately there may be null values in the email because employee may have an email ID or may not have an email ID. So in that case, which will be the primary key? A primary key which is chosen should be unique and it should not accept null values. In this case, I am preferring to go with ID because this ID column in the table or this ID attribute in the table will be 100% unique in the table. So there will be no duplication of values. If 101 is there, there will be no employee in the same table with the same ID value 101. So only one time that value will be existing in the table. So this is 100% unique. There will be no duplication and at the same time every employee will have the ID value. So it is unique and not null. From the super key, we derived the candidate keys. From the candidate keys, we are going to choose one of the keys as the primary key. Remember, the primary key is chosen from the set of candidate keys. We have 4 candidate keys here and I am choosing one of the keys as the primary key, which is ID. and this ID is chosen based on two factors. One is it's unique and the other one it is not null. Now who is going to choose that? I can either go for ID or I can even go for SSN, right? Then who is choosing this primary key? It is chosen with care by the database administrator. See, such a powerful position he is having in terms of databases. He is the one who controls the entire database. So he is the one who chooses the primary key from the set of candidate keys. Remember, in a table we can have n super keys and we can derive a lot of candidate keys. From the candidate keys we can have only one primary key, because this key attribute will never be changed or very rarely changed. Remember, there is an employee with the ID 101. So we will not change the value of this ID 101 to a new value, because this is how a database should be constructed. We are choosing the primary key attribute. It's not only just based on uniqueness and not null features, but we should also consider that the values present in that attribute should not be changed, never be changed, or very rarely changed. Remember, candidate key with null value is not chosen as the primary key. In the set of candidate keys, we have chosen ID as the primary key because it is unique and not null. We may also consider SSN, but we cannot consider this name plus phone number or email as the key. The reason is this candidate key, name plus phone number or name phone number, is having an attribute which can support null values. At the same time, email also can support null values. So one of the keys in the set of candidate keys is chosen as the primary key, and the set of candidate keys with null value is not the primary key, because primary key should contain unique values. Also, there should be no null values. Simply, primary key is unique plus not null. We are done with the third key, the primary key. Let's now focus on the fourth key, the alternate keys. So far we have seen super key, candidate key and primary key. And for this employee table only, we derived some keys, the super key, candidate key, and we have chosen the primary key. Now what is an alternate key? In the set of candidate keys, the key other than the primary key is actually the alternate keys. We had the super key. From the super key, we derived the candidate keys. Let's say there are 4 candidate keys and one of the candidate keys is chosen as the primary key. So there are 3 candidate keys left, and these candidate keys are referred as the alternate keys. So alternate keys are the keys which are not primary keys. In the example that we are dealing, we have already chosen the candidate keys as ID, SSN, name and phone number and email. There are 4 keys. And which key is chosen as the primary key? ID is chosen as the primary key. Now what are the remaining keys? SSN, name and phone number and email. So these keys are actually the alternate keys. What are they? SSN, name and phone number and email. So we are done with the alternate keys. Let's now focus on the next key, the unique key. See, there are situations where we may need to choose a key. That key is unique in terms of values, but it can also have null values. In that case, we are calling that as a unique key. If you are not clear, just see this example. We have already chosen the candidate keys, ID, SSN, name, phone number combo and email. And we have chosen the primary key, which is ID. So obviously the alternate keys are SSN, name and phone number and email. Now what is a unique key? Just pause this video for a while and think which of the keys may contain 100% unique values, but it can also support null values. SSN, if it is 100% unique and 100% not null, so this can be a unique key. Remember, this will not accept null value. And coming to email, this is unique. Every employee will have their own email ID, but if employee does not have an email ID, then it can have null values. So it is unique, but it can have null values. And coming to this example, name and phone number, there is an attribute in the key that can support null values. But there is an attribute which says unique plus not null, but there is an attribute which can take null values. It can give uniqueness, right? So the unique key can be name, phone number, or even email ID. And now let's move on to the next key, the composite key. I'm not going to show that in a new slide. If you see in the set of candidate keys, this is only one attribute. One attribute is working as a key here, and only one attribute is working as a key here. But in this key, can you see here, there are 2 attributes forming the key. So when you have a key that is comprised of more than one attribute, that key is called as a composite key. In this, name, phone number is the key that contains more than one attribute. We can also have another composite key, SSN plus phone plus email. So that is also a composite key because it contains 3 attributes in it. That key contains 3 attributes, more than one attribute. So we are done with the unique key and the composite key as well. Before we sign out, let's see the last key, the foreign key. Now what is this foreign key? This foreign key is unlike other keys that we have seen, because in all the other keys that we talked about, those key deals with only one table. But foreign key actually deals with 2 tables. Let's take student table and let's also take department table. Just see, this department table contains 2 attributes, department code and department name. And this department code will be obviously unique in this table. And let's say this department code is the primary key attribute in this table. And we also have a student table, and obviously student ID is going to be the unique attribute or the primary key attribute in this table. We know student table is having 4 attributes: student ID, student name, department code and credits. And department table contains department code and department name. Now whenever I am going to insert some record here, say for example 105, 104 I cannot insert, already 104 exists because student ID is a primary key attribute. Let's say I am inserting 105, name is Rishav, the department code is 200. This row will not be accepted because I am trying to insert the department code 200, where this 200 is not existing in the parent table, the department table. So only all these 4 values, 101, 102, 103, 104 only are accepted in this table. And whenever any row that is inserted, that row should contain the department code which exists in the parent table. Only these 4 values are accepted. So in that case, one table is referring another table. That is, the student table's department code is referring to the department table's department code. So this integrity constraint we call as referential integrity, where the insertion in one table is actually depending on the values to be validated in the other table. That value should exist in the other table. And foreign key offers referential integrity. Anyway, when we see SQL topic, at the time I will be explaining more about all the integrity constraints. For now, just understand referential integrity is achieved by using foreign keys. Before we sign out, I wanted to say one thing. Please understand the concept of keys clearly, because when we deal with the chapter normalization, there we are going to deal with the functional dependencies. At that time, the concept of keys should be clear. And that's it guys. I hope you liked the video and thank you for watching.